Welcome to this deep dive, brought to you by Safety One Source. Today, we're really focusing in on a question I know comes up a lot for safety professionals, risk managers out there. When you're cutting brick concrete block, is a wet saw absolutely required?
Yeah, it's a common one.
We've got a 2006 OSHA response letter, the Galvin letter, and we're digging into parts of OSHA standard 1926.55 to, cut through the noise. Our mission today, simple. Let's get crystal clear on what OSHA actually says about wet saws and, maybe more importantly, understand the safety thinking behind it all.
Exactly. And, for everyone listening who's dedicated to workplace safety, and if you're here, that's probably you really getting into the nitty-gritty of these OSHA regs, especially for common stuff like cutting masonry. Well, that's key.
It's what makes a difference.
Absolutely. Yeah. Good safety versus really solid preventative safety. So let's dive in.
All right, let's get straight to it, that core question. Does OSHA mandate wet saws for brick and block? This 2006 OSHA letter, the one to Maria Galvin, it points us directly to 29 CFR 1926, subpart Q, specifically section 1926.702I. That's the section on masonry saws.
And what's interesting right away is what that section 702I actually requires. It lists two very specific things.
Okay, what are they?
First, the saw needs to be guarded with a semicircular enclosure over the blade. Pretty standard guarding idea.
Right.
But second, and this is key, that enclosure has to include a method for retaining blade fragments.
Retaining blade fragments. Okay, so why that specific detail?
Well, the OSHA letter explains it. When you're cutting hard stuff like brick or concrete block, there's a real risk. The blade can heat up, get stressed.
The pieces can break off.
Exactly. And think about how fast that blade is spinning. Those fragments become tiny, dangerous projectiles.
Flying metal. Yeah, okay. I see the risk to the operator, anyone nearby.
Absolutely. So that requirement, the method for retaining fragments, it's a direct answer to that specific hazard. It's about stopping those projectiles.
Makes sense. And is this where the wet saw kind of comes into the picture?
It is. Because the letter points out a major benefit of wet saws. The water constantly cools the blade.
Ah, so less heat, less stress.
Less likelihood of the blade failing and fragments breaking off in the first place. It directly tackles that root cause.
So while subpart Q is focused on let's say, the mechanical guarding the enclosure, catching fragments using a wet saw helps prevent the hazard from even happening.
Precisely. It's sort of an inherent safety feature in that sense, addressing the heat issue.
Okay, so that covers the flying blade bits. But, as safety pros listening know, cutting masonry isn't just about the blade. There's the dust.
Ah, yes, the dust. And specifically silica dust. This is a really critical issue.
Why is that?
Because brick, concrete, masonry, they usually contain crystalline silica. Cut them dry, and you release these incredibly fine dust particles into the air.
And breathing that in, not good.
Definitely not good. Long-term exposure can lead to silicosis. That's a nasty, irreversible lung disease, plus an increased risk of lung cancer. It's serious stuff.
The silent killer, almost.
You can say that. It's not immediate, like a blade fragment, but the long-term consequences are severe.
Okay, so how does OSHA handle the dust part? Does that subpart Q we mentioned cover it?
And here's where it gets interesting. The Galvin letter clarifies that subpart Q, the masonry saw standard, doesn't directly address the health hazards from the dust.
Really? So where do we look?
It points us over to a different standard. 29 CFR 1926.55, that's the one covering exposure to hazardous substances in construction, including dusts.
Okay, so different sections for different hazards. 702 for the saw mechanics, 1926.55 for the airborne stuff.
Basically, yeah. Think of it as immediate physical injury versus longer-term health risks from exposure. Both critical, but covered slightly differently.
So what does 1926.55 actually require employers to do about this dust?
Well, subsection A lays down a fundamental rule. Employers have to prevent employee exposure to concentrations above the threshold limit values, or TLVs.
TLVs. Okay, what are those based on?
These specific TLVs in 1926.55 are based on guidelines from the American Conference of Governmental Industrial Hygienists, the ACGIH, from way back in 1970. They're listed in Appendix A of the standard.
And silica is definitely on that list.
Yes, the letter confirms silica is covered by those TLVs in Appendix A. So there are defined legal limits for how much airborne silica construction workers can be exposed to.
Got it. Those TLVs are the benchmarks safety managers need to hit, or rather stay below.
Exactly.
So how do employers stay below those limits? What does the standard say?
This brings us to subsection B of 1926.55, and it outlines something really foundational in safety, The hierarchy of controls.
Ah, yes, the pyramid. Engineering controls first.
Precisely. The standard is very clear. Administrative or engineering controls must be implemented first whenever they're feasible.
Change the process or the environment before you just give someone a mask.
That's the principle. Engineering controls, like using a wet saw or dust collection, come first. Then administrative controls, like limiting exposure time, personal protective equipment, PPE, like respirators. That's the last line of defense.
Only when the other controls aren't enough to get below the limit.
Exactly. It shouldn't be the default go-to if engineering or administrative controls can feasibly do the job.
Okay, so connecting this back. The wet saw, where does it fit in this hierarchy for controlling silica dust?
Right. The OSHA letter makes a really key statement here. It says that while OSHA doesn't specifically mandate wet saws.
Ah, so it's not an explicit, you must use this.
Correct. But, and this is the crucial part, its use is a means of meeting the engineering control requirement in Section 1926.55A with respect to silica dust.
So OSHA sees it as a primary acceptable way to engineer out the hazard.
Exactly. It's a recognized, effective engineering control because it suppresses the dust right at the source of the blade hitting the material.
And does the letter give any idea how effective it is?
It does. It mentions studies suggesting wet cutting can reduce average respirable dust levels by up to 94%.
94%. Wow, that's huge.
It really is. That's a massive reduction. It makes a very strong case for why it's considered such a good practice,
Yeah, that number really drives it home. Okay, but what if using a wet saw just isn't possible on a job? Maybe water access is an issue, or the specific task makes it impractical.
That's a fair question, and the letter acknowledges that feasibility can be an issue sometimes.
So what's the employer's responsibility then?
The responsibility doesn't go away. If wet cutting isn't feasible, the employer must implement other feasible engineering controls.
Like
Using saws equipped with high-efficiency dust collection systems, vacuums designed to capture the dust right at the cutting point.
Okay.
And if those engineering controls alone still don't get the exposure below the PEL, then they need to look at administrative controls too.
Like limiting how long one person does the cutting, retaining job.
Things like that, yes. Anything procedurally that reduces an individual's overall exposure time.
But the letter adds a pretty important warning here, doesn't it? About relying only on dust collectors.
It does. And this is a really practical point for safety folks. It points out that dust collectors, even good ones, often are not sufficient by themselves to reduce silica exposures below the permissible limits.
So even with a vacuum running, you might still be over the limit.
It's quite possible, yes. Which means, in many dry cutting situations, even with dust collection, respirators are probably going to be needed as well.
That additional layer of protection.
Exactly. It highlights that need for a multifaceted approach when wet cutting isn't feasible. Engineering controls first, but likely supplemented by PPE.
And choosing the right respirator is key, I imagine, not just any mask.
Absolutely critical. The letter stresses the need to do an occupational exposure determination. Basically, you need to measure how much silica dust is actually in the air for that specific task.
Find out what you're dealing with.
Right, because only then can you select a respirator with the right assigned protection factor, or APF. You need to make sure the mask is capable of reducing the exposure from the measured level down to below the PEL for the person wearing it.
Makes sense. You need the right tool for the job, even when it comes to PPE.
Precisely.
Now, the Galvin letter also throws in a reminder about some basic stuff, regardless of wet or dry cutting.
Yes, absolutely. Eye and face protection.
Can't forget that.
All right, what else you're doing? Wet saw, dust collector, respirator. The requirement in 29 CFR 1926.55A for eye and face shields is always there. Flying debris is always a risk with cutting.
A fundamental baseline. Good reminder.
And there was a quick mention of another letter, O'Donovan, something about enclosed spaces.
Yeah, it was a brief reference, kind of an aside, related to a different scenario back in '77. It touched on ventilation and hazards like flammable gases or materials in enclosed construction areas.
So not directly about wet saws, but related to overall hazard control. Exactly. It mentioned things like prohibiting open flames for heating if you've got, say, flammable tarps enclosing the space. It just reinforces that broader principle. Always assess all the potential hazards in the work area.
Got it. Safety is about the whole picture. Okay, let's circle back to 1926.55 and those permissible exposure limits, the PELs. We mentioned them, but maybe we can unpack them a little more for the listeners managing safety day to day.
Sure. So as we said, subsection A points to tables 1 and 2 for the limits. These tables define hazardous levels for different airborne contaminants.
Right.
Table 1 mostly lists substances with limits in parts per million, ppm, or milligrams per cubic meter. Some of these have a C next to them.
C for ceiling. What does that mean practically?
A ceiling limit means the concentration that an employee's exposure should never exceed, not even for a short period. If you can't monitor continuously, you typically take a short, maybe 15-minute sample to check against that ceiling. It's an absolute maximum.
Okay, never go above that line. What about the limits without a C?
Those are generally 8-hour time-weighted averages, or TWAs. This means the employee's average exposure over a full 8-hour shift shouldn't exceed that limit.
So exposures can fluctuate a bit during the day, maybe higher for a short task, lower later?
Correct, as long as the average over the whole 8 hours stays below the TWA limit.
In Table 2, that's the one specifically for mineral dusts, including our friend silica.
Exactly. Table 2 is where you find the PELs for different types of silica, crystalline quartz, cristobalite, amorphous, plus other dusts like talc or mica.
And how are those limits expressed? Not ppm.
No, for these dusts in Table 2, the limits are given in MPCF.
MPCF. What's that stand for?
Million particles per cubic foot of air. So instead of measuring weight or volume concentration like in Table 1, here they're essentially counting the number of dust particles in a set volume of air.
Ah, okay. Particle count versus concentration. And it's this Table 2 with the MPCF limits for crystalline silica that's most relevant for cutting brick and block.
That's the one. That's where you find the specific actionable limits for the hazard we're focused on today. We don't need to memorize all the numbers, but knowing that these tables exist and define these exposure limits is critical for safety management.
Understood. And just quickly, you mentioned subsections C and D exclude asbestos and formaldehyde?
Right, just a clarification point in the standard. Those substances are so hazardous, they have their own, much more detailed, separate OSHA standards.
Yeah.
So 1926.55A and B don't apply to them.
Got it. Keeps the scope clear. Okay, so let's try and pull this all together. What are the key takeaways for the safety professionals, the risk managers listening?
Okay, the big one. OSHA does not explicitly say you must use a wet saw for brick and block. There's no single sentence stating that mandate.
But
OSHA clearly recognizes wet saws as a very effective engineering control for silica dust. Using one is a primary method to help employers comply with the legal exposure limits set out in 1926.55.
So it's strongly implied as a best practice and a means of compliance, even if not explicitly mandated in that one rule.
You got it. It's about meeting the requirement to control the hazard, and wet cutting is a great way to do that.
And if wet cutting isn't feasible,
then the employer absolutely must use other feasible engineering controls, like good dust collection. Often administrative controls might be needed too. And crucially, respiratory protection will likely be required as well, because dust collection alone often isn't enough.
Remember that hierarchy of controls. Engineering first, then admin, then PPE is the final layer.
That's the core principle. Understanding and applying that hierarchy is essential for protecting workers from silica and for meeting OSHA requirements.
Okay, so here's something to chew on for everyone listening. A final thought. We know silica dust is dangerous, serious long-term health risks. We know wet cutting is highly effective. That 94% reduction figure sticks with you. So even if it's not strictly mandated in every single scenario by the letter of the law, what practical steps or maybe innovative approaches can you as safety leaders champion in your workplaces to make wet cutting the default choice whenever possible?
That's a great challenge. Thinking proactively.
Yeah, think about the long game. Worker health, reduce future liability, just building a stronger safety culture. How can we push for the best practice, not just the minimum requirement?
And remember, as the OSHA letter mentioned, there are more resources out there. OSHA's website has a lot on silica, recommendations, their special emphasis program.
Yeah.
Worth checking out.
Absolutely. Keep learning, keep improving. That's what it's all about.